Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of the Kubernetes series. We have already started a few episodes on it. We saw how to collect metrics, how to collect logs. We also saw service mesh and Istio. Now, it's related to Kubernetes, but in fact, it's also beneficial for any environment using Prometheus. We can almost say that this episode is part of the Prometheus series, in fact, because we will focus this episode on one of the language called Prometheus Query Language, PromQL. So if you enjoy today's content, don't forget to like and subscribe to the channel. What are we going to learn out of this episode? So first, we're going to introduce the various data type handled by Prometheus. This is very important, we'll see, because when you're going to do some PromQL, it's important to understand those different data type. Then we'll jump into the various formats of data available in Prometheus to store our metrics. So if you're planning to build an exporter, that will be very useful for you. Then we will jump into the various way of filtering the data. And last, we'll see the various operators. And of course, like usual, we'll do a small tutorial on building few queries using our kubestate metrics and node exporters that we have previously installed on the previous episode. So, PromQL is essential when using Prometheus, because basically PromQL is the main language that will help you to visualize the data in Grafana or Prometheus, or even build alerting rules. So without knowing anything about PromQL, it will be very difficult to take advantage properly of Prometheus. So let's see the Prometheus data type. So when you apply a PromQL, Prometheus data will be evaluated in 4 types of metric. So we have string, Scala, range vector, and last is instant vector. So we already had an episode on Prometheus. We saw the architecture and how to deploy it and the various components involved. And we mentioned on this episode that Prometheus store the metrics scrapped from the various collectors in a time series database. Which means technically what happens is that you have an identifier for your metric that you are planning to store. And then it will be stored related to the timestamp where we were able to collect that data. So at the end of the day, we can say that in the Prometheus storage, we will have time series 1, value 1 for metric A, for example. And then same thing, timestamp 2, value 2, timestamp 3, value 3, and so on. So the structure of the identifier will, of course, you will have a metric name, but in Prometheus, you also have the notion of labels. So here we have an example of a metric. So HTTP request total, and you can see that there are, after the name, there are a couple of the various labels that comes along with it. So you have usually the job. So the job will be, where did I scrap that metric? So basically it's the job will be the name that you have defined in your scrap configuration file of Prometheus. Then in this example, you see that there is a second label called method. So you can have, in our case with the HTTP request, we know that we have different type of requests with their various methods. So the get, the put, the post, and so on. And then you have the path. The path is basically the endpoint of our request. So with those couple of labels, the advantage is that we will be able to filter, we'll see that later on, the data stored in our time series database. In fact, technically, the metric is stored in a sort of JSON object, so this is the other representation of the metric. So you see the various labels that we previously described. And last, you have another one called __name __. And this is basically the name of your indicator. So if you will see that in the filtering, we can also try to filter to say, I'd like to collect all the metrics starting with HTTP requests, for example. That will be also possible to achieve due to this structure. So when we run PromQL, we mentioned Prometheus will transform the data and present it on various formats. So there are form formats we mentioned. So the string format, I mean, no surprise, it's a string, so it's a text. So when we run a query, Prometheus, depending on the function that you use, will transform it and return a string. Simple. Then you have the scalar. Scalar is basically a numerical value. So this is also very simple to understand because we're used to that in our IT world that we were all working on. But then there is the two other types, which are a bit more complicated. So instant vectors and range vectors. So let's start with the first one, the instant vector. So the data collected by Prometheus, they will never come and stored at the same moment. Remember, you have Prometheus that will reach out to the various exporters to collect the various data. So which means I can start with one exporter, then the second one, the third one, and so on. So all the metrics arrive in Prometheus at different timings. So when you run a query on a specific metrics, you can evaluate the data based on a time, current time, or let's say a specific time. So if I use, for example, this query with rate, CPU memory usage total, with various labels, so the host, the type, the namespace, and so on, then at the end here, I'm adding like a filter on the timing. So the 30 seconds means evaluate the rating from now to the last 30 seconds. So this query will return the value of the CPU memory usage per second over the last 30 seconds. So instant vectors is basically, it gives you a value, one value for a series. And if you don't precise, it will be the last value reported. So instant vector, one value for a specific timing. At the opposite, you have the range vectors. So it's a range. So which means it's not going to be one value, it's going to be a set of values measured between two timestamps. Maybe now and last month, or last week and last month. So keep in mind that, instant vector, one value, range vectors, a set of values that you will basically be able to collect. So now let's see the various way of storing the data in Prometheus. So if you're planning to write your own Prometheus exporter, it's going to be very crucial to understand those various data types, because you will have to select the right one depending on the nature of your metric. But even if you don't plan to write your exporter, it's very important to understand those various data types, so then you can utilize the right functions depending on the data type. So what are the data type available? So you have counters, you have gauge, you have histogram, and you have summary. You will have to select the right set of data type depending on your use case. So, for example, if you build your exporters, there are plenty of HTTP Prometheus clients to allow you to build your exporters. You have the Go language exporter client, you have the Java client, you have the Python client, the Ruby, and so on. So those clients are usually very easy, and there's a set of functions depending on the data type. So when you write your exporter, you have to say, I want to have a counter. You give a name of that counter, and then you will basically increment or set values in that counter. So there are a couple of methods, helpers to allow you to achieve the building of your exporters. And it's very, very simple, to be honest. So let's see the first one, the counter. So the counter type is a type aimed to store metric that will increase in time. So, for example, let's say the request count. This is going to be increasing in time. The error count, it will increase also in time. A total, for example, if I'm counting the number of bytes that I'm writing a disk, that could be a counter as well. So counter should not be used for metrics that decrease. It's not aimed for that. So what's the purpose of a counter in Prometheus? Well, you usually use counters for, like I said, metric that always goes up and totals. And there are plenty of metrics, by the way, there. So what you can achieve in terms of query, because counters are very specific and it's very hard to correlate or understand a pattern related to a counter. So that's why there is one function that will only support counters, and this function is basically used everywhere in most of our PromQL. It's rate. Rate takes as an input only counters. So you need a metric name, of course, and the period of the time. And rate basically is returning the per second of this given counter. So if I say, in our example previously, we had the HTTP request count. So if I said the rate of the HTTP request count, it will mean that we'll have the number of HTTP requests per second for a given period of time. And rate is returning an instant vector. Remember that. So the biggest limitation of counters is, you have to know that, is that for if some reason your exporter is basically crash, then if Kubernetes restart your exporter, then the counter will restart from 0 and it will keep incrementing again and again. So it means that you have to consider this challenge when you are using counters or when you are planning to build PromQLs with counters. The second type is gauge. Gauge can be used for metrics that could go up and go down. So, for example, the type of metric that goes up and down, response times, memory usage, CPU usage. I mean, there is so many counters. It's not counters, sorry. It's a lot of many indicators that goes up and go down. So gauge will be a lot of used quite often. So how you can query gauge in Prometheus? There are also functions or operators, I would say, that will take as an input gauge, and those usually are aggregated functions. So like average over time. So if I take the average over time of an HTTP request during a specific period, then that will return me the average response times over the last, let's say, 5 minutes, for example. Rate, of course, we mentioned, it's only made for counters, so don't use rate with gauge metric. The third type is histogram. So histogram will allow you to specify a value for predefined buckets. So let's say I want to report the HTTP response time and the response size, for example. So every time I use histograms to report, let's say I have 2 seconds, then Prometheus will take my response times and will basically count the number of requests that were fitting in a specific buckets. And so let's say we have a bucket like between 1 and 2 seconds. So the 2 seconds will fit in the 2 seconds bucket. So histogram will count the number of requests or indicators that had the value in our buckets. In fact, there is a default bucket, which is here. You can see that there's a clear structure of the buckets. So the default bucket will only support metrics that goes up to 10. So 10 seconds if it's a request response time. So if you need to report a metric that will have higher values than 10, then you will have to define your custom metric. So it means that you need to know how the minimum value potential of your potential metrics and the maximum value of a potential metric. So then you can structure correctly the buckets depending on your need. Histogram are usually used to report any measurement of a value to calculate, let's say, averages, percentiles, and others. So if you're not interested to get the raw data out of your measurement, then histogram will make a great job. So gauge will be like raw data, and histogram will be like aggregated metrics. So Prometheus also, when you use histogram, will automatically store the number of elements in the histogram and the total number reported. So we can easily then calculate averages. So let's take an example. Here we got rate with a metric duration, sum over the 5 minutes. And then also the sum is automatically calculated by Prometheus with the help of the histogram. And then you can do the rate of the other default metric that is calculated is the count. So I'm taking the sum divided by the total number of metrics, and that, surprise, give me an average. Simple like this. So, and then of course, every time you have to precise the timings over the last 5 minutes or for a specific time stamp. We can also, with histogram, there is also predefined functions to allow you to calculate percentiles. And this function is histogram_quintile. So if I do histogram_quintile of 0.95, and then I precise the operators. I said sum of the rate of the request duration buckets, for example, on 5 minutes. And when I do the sum, we'll see it later on, you can use an operator by that will basically split the metrics on several dimensions. Last is summary. So summary is very, very close to histograms. So let's say histogram has function. We saw it to calculate the histogram quantile to calculate the percentile. So basically it means that I can basically calculate percentiles on the Prometheus server by using these functions. In summary, it's different. You will have to calculate it on your exporter. So summary data cannot be aggregated from a number of application instances. Histogram requires to use default buckets, we mentioned that, or define your own buckets. And if you're working or utilizing a metric where you don't necessarily know the values, so it's very difficult to predict those values in advance to design the right buckets, then summary would be perfect for your case. Because we don't know the values yet up front, so it makes sense. I don't want to define that bucket, so I'm going to use summary for that. So we usually use summary when we need to collect as many measurements and then later on calculate averages percentile. So if you're not interested in raw data and precise values of your metric, then summary will make a great job for you. So we can use summary for response times, response size, or number of bytes exchanged, or IO write inner disks to build again those buckets. Let's see now the way of filtering the data, because at the end we're going to do some PromQL, so we need to filter. So we saw that our Prometheus metrics has labels. So there will be, of course, a label filtering operator. So that will allow us to filter the metrics that we have stored in our time series database. So we have operator like equal. So it means that select labels that are exactly equal to a provided string. Then we have not equal, simple, not equal to that string. And then we have all the regular expressions operations. So either a positive regular expressions or a negative regular expression. So one important concept that you need to keep in mind is that you need to use a filter in your label filtering that is not an empty string. So you cannot do, for example, equal to nothing. Doesn't make sense. This request is forbidden. It's bad. Now, equal nothing, you will never do it, of course, but I'm telling you that because if you're planning to use regular expressions, make sure that your regular expressions always return a value. So if you do this regular expressions with that nature, with that expression, there's a big chance that we return empty strings. So that is a bad query. You should probably replace it with this expression that says at least one character. The second type of filtering is the range operator, where you can specify a time duration that will filter vectors between now and a specific timing. So we had a couple of examples previously, and those were basically range selectors. So time durations are specified as a number, so 30, and then it follows by the units of the time. So you have several units available. So you have milliseconds, you have seconds, you have minutes, hour, days, week, and last, you have, of course, years, months, and so on. Then you have offset. It allows you to request a value from X second ago, or days or minutes. So similar to the range selector, you need to specify the unit as well. So as an example, I can say HTTP request total offset 5 minutes. So that will return the value of the HTTP request total 5 minutes in the past. Then you have the modifier. So the modifier allows you to change the evaluation date for a specific timestamp. So if you don't use any modifier, by default, it's the current timestamp. So you can combine range selectors and offset with modifier. So let's say we took an example at the beginning, say rate of the HTTP request total of the range of the 5 minutes. And then if I add a modifier at the end, I can precise at which time I'm referring to. So let's say I have the timestamp of last week, and I want to run that query, and that will basically return the number of HTTP requests per seconds of the last minutes at that time, at that date. Now let's jump into the operators. So there are two types of operators in PromQL. So you have the aggregation operators that will only use instant vector as input. So remember, or if you want to do aggregation, you need to transform and only use range vectors, but instant vectors as an input. And it will return instant vector as well as an output. So input instant vectors, output instant vector. So what are the type of aggregation operator that we have? We have sum, we have min, you have max, you have standard deviation, you have averages. There's plenty of them. Now, and then you have the binary operator. So basically arithmetical operations like plus, minus, divided, multiply, and so on. You have comparison operator like equal, not equal, less, greater than, and you also have and, or, unless. And then there's also a couple of functions. So rate, we mentioned that. Rate takes as an input a range vector, and it will measure the per seconds of a counter. Remember, a counter for a given period of time. Rate functions is smart. Why I'm telling you? Because remember, counters could be restarted if our exporter is crashing. And rate is detecting those crashes. So, for example, if the value goes up 1, 2, 3, 4, 5, 10, and then goes back to 0, then the rate has understood that it crashed. So he's going to go back to 10 and go up. So it's very smart. So you don't have to worry about it. He will manage those counter that has been probably restarted. All right, so I think we cover most of the meaningful operators and filters allow us to build queries. So let's jump to the tutorials and make some few examples of queries.
All right, so like usual, every tutorial that you will have in Easy Observable will have its own GitHub repository. So the GitHub today's episode is about PromQL, like we mentioned. So all the steps required to deploy these tutorials at your own environment is here. So we mentioned, we already have with the previous episodes, especially the first one on Kubernetes and Prometheus, we already have deployed Google Cloud Kubernetes cluster and GKE. We have deployed Prometheus and Grafana, and that's it. So we are not going to do those steps. We are going to focus directly in the PromQL. So let's jump into Grafana. So in Grafana, like we had in the previous episode, the storage, the data source of Prometheus has been already configured. So then we can either run our queries in Explore, either run our queries by building a dashboard, looking at the metric itself. So let's do Explore for our case. And for this tutorial, I'd like to go through various things. We have the node exporter and a kubestate metrics. So I want to basically look at few metrics, and there is one metric exposed by the kubestate metrics. It's the kube pod status phase, and we're gonna just type it. So the great idea is that great thing with Grafana is that it's you can see the metrics coming in here. You don't have to exactly know all the metrics, so it helps you to search for metrics. So let's do pod status, and the one we're looking for was the phase. So we are going to simply run that query. And why? Because we want to see the label. So the first thing that we want to do is look at the various labels that we have and try to use some few label filtering. All right, so we can see here in this particular metric, kubepod status phase, that we have endpoint labels for the endpoint, instance, job, namespace, phase, pod, and so on. So let's try to use a query, for example, that, all right, I like to only look at the phase field for the namespace hipster shop. All right. So similar to what we did before, we need to put the bracket here to see the various labels. So with completion, it also gives you the various namespace. So we want to have the, we set the phase equal failed. And the second condition would be on the namespace equal hipster shop. So let's run that query. So now it's going to basically return for us just instant vectors. So we don't have any counter here, but we could basically now play around with few functions. So let's say, for example, from this query, failed doesn't make sense, but let's say I'm interested in counting the number of running pods per namespace. So so let's remove first this namespace filtering. Let's put the right filter, which is running. Here it is. And now we want to do a count. All right. So count is an aggregating functions. So here it is. I'm taking count. And which is great with all those aggregation functions is that you have the by operator. So then in the by operator, you could basically split this counter per, in my case, namespace. So if I run that query now, I have a count. So you can see that I have 19, 15, 12. So here it's showing me each individual values for each of those namespace. So here we are in Explore, which means you're not able to do any visualization. So if you want to transform this one into a graph in the dashboard, so we're going to jump into dashboards and we are going to basically run the same query here. So I'm going to copy paste it here, run the query again. Up here we have the values, and now we could basically says in bar gauge. Why? Because here it says it allows me to basically see the exact number of running pods per namespaces. You hear default, hipster shop, Istio systems, and cube systems. So let's jump into a fresh new dashboard. So I'm going to do a new graph here. So I'm going to add a new panel. And now we want to play with a bit more with the operations. So I'd like to pick a metric which is a count. So either you know the metric, either you have no clue of which is a counter value or not. But there's a rule, to be honest, when you build your metric name. If you put total, then it makes sense that it's a counter. So let's search for total. So if I search with total like this, I will be able to see basically potentially all the metrics that are counters. They will basically increase in time. And the one that I'm interested in is, let's say we want to utilize in the node exporter, there is one metric called the node IO, node disk IO time second total. So this is the one I'm looking for. So now if I run that query, you will see it's going to be a counter with the various values. So let's now use rate. So we have a counter, we know it, and we want to evaluate the number of disk IO time per second. All right. So I'm going to add rate at the beginning here, and I need a range selector. All right. So if we put, for example, let's say 10 minutes or 5 minutes, for the sake of the example, here it is. And then if you run the query, now we can see that we have the number of disk IO per seconds that is displayed in this graph. So you can do pretty much of things here. This is an example with counters. So counters, remember we mentioned that you have to use rates to be able to utilize things. Now let's have a look at any metrics that use histograms. So similar, if you want to searching for histograms, you can basically search for buckets, because this is going to be added by automatically by Prometheus. So here you have plenty of them, and there's one in fact that I'm interested in is the in etcd there is a metric called lease object count. All right, so now we have this one here, but lease object counts, and there's the bucket here. You see the bucket here. And if we, for example, do this query very quickly, we can see that there's a different type of buckets. So it's the customized buckets, by the way, which we can see here. And now I like to report, for example, the histogram quantile, so the percentile 95 of this query. And as you can see, either I can type it, but here Grafana has automatically detected that it's an histogram. So maybe we can add histogram quantiles in the beginning. So which I'm going to click here, and blah blah. I didn't have to type it. It's basically, it was exactly the desired metric that I was looking for. So you can see that we have some every certain couple of hours. We can see that we have a couple of objects that has been leased in etcd. Now, last thing that I want to show you is maybe let's say I like to count the number of objects created in etcd in our cluster. So, and for that, there's also another, similar to this value, there's a object counts. If I run the query, you will see it's the counts that is provided by the bucket. So, and to consume it, we will have to do a rate similar to the previous time. So rates first. So we're going to count the number of object counts, number of objects that we have in etcd. So we can say every 5 minutes, for example. And then I can close this one and I run the query. So now we have the rates of the number of the objects per second that we have in etcd. But now I want to take advantage of the sum. So I have the number of objects per second and I want to do a sum. And why I want to do a sum, or I can do a count. In fact, it's going to be the same thing. And I want to do a sum of the by splitting by dimension. So I want to do, let's say here you can see that resources is the various type of objects that we can find in etcd. So if I do resources, I will be able to split this one. So if I run the query, here it is. So I see all those various resources here. And you can see there's mainly one that is going up quite often. It's the events. It's created. So again, that's a pure examples. What is also interesting here in Grafana is that you have transform. Transform basically is a way of helping you to build a query. So it's basically helps you to design the query. And there's another solution which makes completely sense to show you today. It's a solution called PromLens. So if you go to promlens.com, you can either have access to the live demo, which I'm going to show you, or you can deploy it on your cluster. It's going to be basically an extension version of your Prometheus UI. And what I really like about it is the fact that you can start a query and there's a form. And you can put, and basically here you have a couple of wizards, say which query type you want to do, which metric name, the label filtering, all the things that we were playing around and explaining during today's sessions is basically driven by PromLens. So if you struggle to build a complex queries, PromLens will be a good solution to help you draft those queries.
So that's it for today's episode. I hope you enjoyed this content. If you do, at least don't forget to like the video and subscribe to the channel. And don't forget to put your comment and let me know if there is any specific technology that you would like to have a tutorial on. So please reach out to me. You have all the contact details on the YouTube channel. All right, so see you soon for another episode. Bye.